Okay, any more submissions for the homework assignment, homework 2? All right, I just identified someone who's going to be able to grade the assignments for the semester. I was a little bit worried that I wouldn't be able to find a grader, but I did, and he's going to be a good guy. I think he's going to try and turn these around as quick as possible. But that, in the case of this coming week, it may be Wednesday of next week before you see him because we don't have class on Monday. So ordinarily, it may be a week or a bit sooner. Thank you. Let's take a look at some of these announcements. Homework 3 is due on Wednesday. Did everyone get a paper copy of that assignment? It's also posted on. It's also posted online. If you happen to misplace the paper and want to take a look, hand that back to him. So this includes some book problems and a few problems that I've created on my own. So in italics there, I give you some instructions that you should be sure and show all of your work. Some of these problems maybe you could calculate entirely on your calculator, but of course if you make a mistake, then that doesn't give the grader any opportunity to award you partial credit. And so you can only receive credit for work that you've summarized on the paper, what your thought process was, you know. So write the equation if there's something that you're going to be substituting into. If there are variables that you're assigning to different values you get out of the problem statement, be sure and assign the variables. So A equals and whatever the amount is, for example. So just try and be as detailed as possible. You know, paper is relatively cheap. You don't have to try and cram the entire assignment onto a single piece of paper. There's no sense in doing that. It's just better to be as expansive as possible so that the grader has a full idea of what you had in mind for the assignment. So I'll collect that on Wednesday the 7th, and then the following class period on Friday the 9th, we're going to have our first quiz. Now, don't get too worked up about the quizzes because in comparison to the exams, they have a relatively small weight in your final grade. They're only worth 2% of your final grade. It's really intended as more of an intermediate assessment so that you have an idea, number one, of what my question style looks like for this sort of thing. So you can kind of get a taste before the exam comes around of, you know, the formatting of a question in this course. And then the other thing is it's going to give you an idea of whether the process you're going through of doing some problems in class as an in-class exercise and then translating that into a related homework problem, whether you're understanding the homework problems rather than just solving them. Because there sometimes is a big difference, especially if you've got a study partner who sometimes is helping you along. Just because you have an assignment that you've turned in, and even if the problems are all right, that doesn't necessarily mean that you can repeat what you did one time. So these quizzes may give you an idea of if you need some additional practice problems. So we'll do that on Friday the 9th. And today we're talking about compounding. So any questions about the announcements before we get into it? Last time for the in-class exercise, we had this problem where it was kind of a sequential solution. And in the problem statement, in the cash flow diagram, what we had was a situation that we were receiving loans in an installment. Four payments came to us as inflows, and then there was a single outflow in year 4. Without telling you about compounding in advance, I asked you to solve this in kind of an intuitive way. The idea being, the description that I gave you in these bullet points is, take the amount that you've received in year 0 and then find out how much is owed after the first year. And so, you know, what's the principal plus interest after 1 year? And then I said combine that with the amount that is in year 1 and then move that forward into the future. Later on I showed you my solution where it was showing how on a cumulative basis the money just gets bigger and bigger until finally in year 4 we know the amount that has to be repaid. So you've already sort of exposed yourself to the idea of compounding. We're going to take a look at more formally what compounding is and how it's different from simple interest. One other thing I wanted to point out before we did that is in my solution, a couple of people as I was circulating around was asking me, what is this 1.05? that was appearing in the solution. And the origin of that is if you think about the principal and the interest combined, that's what you owe at the end of the year. And so you have to pay back the amount that you received, the first installment of $12,500, but you also have to pay the interest component of that. And so I'm combining the two things together. So here it was 5% interest per period, so it was 1.05, but more generally, what you'll sometimes see in the formulas is 1 plus I, and then you multiply that by some amount. So if we wanted to find the future amount, then we would multiply the present value by 1 plus I, and then that would tell you the future amount. So just to go back on this solution that I showed you in the previous class period, that's what that comes from. All right, so simple interest we've seen before. And simple interest, if you can ever take out a loan where you're just paying simple interest, that's definitely what you ought to do compared to compound interest, because simple interest is a little bit more forgiving. You're only paying the interest, which is that fee for the privilege of borrowing. You're only paying the interest amount on the principal, which is the original amount that was borrowed. So from a formula standpoint, the interest that you calculate, the amount that has to be repaid, is just the principal times the number of periods and then the interest rate per period. Now again, I'll caution you that sometimes our interest is expressed if the periods are monthly, then you would need to convert the interest rate from an annual interest rate to a monthly interest rate, just by dividing by the number of periods per year. So here's an illustration that shows some calculations related to simple interest. Let's say that there was a loan of $100,000 for 3 years at a simple interest of 10% per year. So this isn't saying 10% over the 3 years. This is per year, but the interest amount isn't going to increase every year because it's just 10% of the original principal that was borrowed that has to be given as that fee. So the interest amount is going to be $30,000 for the entirety of the loan for the 3 years. So there are 3 periods, 10% per period, and $100,000 was the original principal. And so if you combine the interest to the principal, then a total of $130 should be repaid at the end. So you've got the formula here. The sad news is that you'll hardly ever get to do calculations like this because most people want to have more money, most people that are loaning money, and so they insist on compound interest. So let's take a look at how compound interest is different from simple. Okay, so in the case of compound interest, you're paying the interest based on the principal, which is the same as simple. But now in compound interest, you're also having to pay interest on the previously accrued interest. So here it's saying plus all accrued interest. In other words, interest is compounding over time. It's getting larger over time. And so now the interest amount is the original principal plus the accrued interest in previous periods multiplied by the interest rate. There's a formula provided in the book that isn't as complicated as it looks at first glance. This formula is to tell you how much interest has to be paid during period T. So period T you can think of as this year, and period J, the other component here, is last year. So what this formula is saying that the interest amount you have to pay this year depends on the principal that was borrowed plus all of the interest that's accumulated in previous years. And you combine those two things together, the principal and all the previous interest amounts, and multiply it by the interest rate per period, I, and that tells you how much interest is due this year. Any questions so far about compound interest or about this formula? Let's look at the same thing, the same amount, but compounded rather than simple interest. Okay, so this is the same $100,000, and it's still 10% per year, But in this case, instead of being simple interest, it's compounded annually. So we want to know after the full 3 years how much is going to be due. In the previous example, it was $130,000 when it was simple interest. So what is your guess? Is it going to be more than $130,000 or less than $130,000? More. Why will it be more? Right. So the interest for each subsequent year after the first year is going to be paid on the principal and the previous year's interests. So the first year is the same. Simple versus compound. You don't see any difference in year 1 because in 0 you didn't owe any interest yet. All you owed was the principal. And so year 1 is simple, or straightforward, I guess I should say, for sake of clarity. The $10,000 that you owe is just the 10% of the $100,000 that you originally borrowed. But now at the end of year 2, you're going to have to pay interest on $110,000, not just on $100,000, because if you had wanted, you could have paid everything off at the end of year 1, but instead of paying it off at the end of year 1, you continued with owing the money, and so you have to pay the interest on the total amount that you should pay by now. And so you can see in year 2, it's the fee for borrowing the money is still 10%, so that the interest rate hasn't changed in the second year, but the interest amount has changed because it's based on the new balance. And the new balance is $110,000 instead of in the previous year the balance was just $100,000. And so when you combine the two amounts, the new interest amount from this year and then the previous balance, $121,000. And so this extra $1,000 here, the extra $1,000 is the interest on the interest. So this, let's see, the interest of $10,000 that you had accumulated during year 1, you're paying interest not only on the principal, but the interest on the interest. And the same trend continues from year 3. And so by comparison, if you had just paid with a simple interest loan, the total amount due at the end of the 3 years would be $130,000, but with compound interest it ends up being $133,100. The effective compound interest is much larger if, number 1, you have a higher interest rate, and number 2, the frequency of compounding. This was annual compounding, meaning that the bank sits down and does the calculations at the end of each year. There also happens to be monthly compounding, or even in the case of credit cards, they do daily compounding. And the reason for that is the more frequently you can do the calculation of how much is owed, that means that you come up with a new balance more often, and then you can start charging the interest on the updated balance more quickly. And so we'll take a look at that in subsequent in-class exercises, the difference between annual compounding and monthly compounding. And you'll see that the more frequently the compounding occurs, the higher the amount you have to pay. So in addition to differentiating between simple and compound interest, we can also differentiate between nominal and effective interest. And this kind of comes into play when we were looking online at loan amounts. You saw that sometimes the loan amounts were quoted as a rate, and sometimes they were quoted as an APR, an annual percentage rate, which takes this effect into account. Nominal interest is when the interest is compounded more than once per year but is quoted on an annual basis. So it's just so common for us to refer to things on an annual basis that even when interest is compounding quarterly, we still like to refer to it on an annual basis. So the effective interest is when you are actually dividing that into the interest amount per period. So 16% divided by 4 means that you'd have 4% per period. But there's a formula that allows us to translate between effective interest and nominal interest per year. I here, the result of the formula is the effective interest rate, where the nominal interest rate per year, R, in this previous example of 16%, the effective interest rate is going to be higher than 16% because you're having to pay interest on interest. So nominal is really what the bank wants you to think about. Oh, I'm paying 16% per year. But the effective is going to be higher than that because of the interest upon interest that you're going to have to pay. So in this case, if we had 16% per year, what we would do is we would have R is 0.16, M, the number of compounding periods per year, if it's quarterly, would be 4, and then you'd take it to the power of 4. So let's take a look at that calculation. Okay, so 1 plus 0.16 divided by 4 to the power of 4, and we're wanting to find here the effective interest, and then you can see we have to also subtract by 1. So do all of you have calculators here today? Do that calculation and let's find out what is the effective interest rate if the nominal is 16% and it's compounded quarterly. And I'll do the calculations at the same time. I've got a good calculator app on my phone. Did you get 16.99%? Essentially 17%. That's a big difference. It may seem like, oh, 1% isn't so bad, but when the loan amount is high and when you're just paying, let's say, the minimum balance, and so that the loan amount isn't retiring very quickly, then it can result in a lot of extra money being paid on a loan if you had in your mind you were paying nominal, but really what you have to pay is the effective interest rate. Any questions about that illustration? All right. So I have an in-class exercise for you today, and it's just a bunch of questions related to compounding. Not a bunch. There's 5 questions. So remember that the cash flow diagrams are kind of like a problem statement in the form of a picture. You're going to also become acquainted with this bracketed notation here. It's kind of a way of summarizing a solution strategy. And do you remember what F/P means from the previous class, last time when we were talking what is F/P? Yeah, find F given P, exactly. And what I mentioned to you last time is you can think of it as a ratio. So the ratio of a future amount, so a future amount divided by the present amount is this formula, 1 plus I to the n power. So I here should be expressed as a decimal. So if you have an interest rate of 16%, what that means is that you're going to have 0.16. But if it's 16% per year, and oops, that's not the erase. If it's 16% per year and there are 4 compounding periods per year, then you'd need to have I is 0.04. So be sure that you ask yourself, what is the compounding period? So what these summaries here is F/P, I percentage, N. You'll solve problems and you'll be able to just sort of set up the problem, find the equivalent formula for it in kind of a concise way, and then more complicated cash flow diagrams where you've got a lot of steps reduced down quite a bit easier than they would otherwise. So the ratio here, if you know the present value, you can find the future value just by multiplying this formula by P. All right. So let me hand out this paper. As always, I welcome you working with your classmates on this, and I'd like to at least take a look at what you did before you finish up for the day. You know, everybody sort of works at a different speed, and so if you finish quickly, I don't expect you to stay while everyone else is working on the exercise. But it's not a bad idea to get an early start on the homework as well. So, you know, if you do finish quickly, maybe you should read over the homework problems, and if there's something that you don't understand or you want to have clarified, then I'm here to help you with that as well. There you go. Okay, I was walking around and I think most people did great on these first two problems, finding F and finding P with the same formula. Just the difference is what's the unknown in the expression. So it makes it really easy to do the compounding this way when you just have the number of compounding periods as the n up in the exponent. So any questions from the first two? Okay, problem 3 is a little tricky, and the irony is I've seen so many students making the same mistake. You got to be careful about the different interest rates. The banks are hoping that you'll miss it, and so it's easy to not see that Plan 2 has a different interest rate than Plan 1. So the key to this one is that you've got this Plan 2, 7.25 annual interest. Even though that's annual interest, it's compounded monthly. So this annual of 7.25, that is the nominal. That's not the effective that they're quoting there. So what you need to do is find out the interest rate per period. There are 12 periods of compounding each year, and so the interest rate per period is going to be 0.0725 divided by 12. Was there a question over here? I thought I saw somebody's hands up. So the difference between the two accounts is just $100. I think on the handout I gave you, I changed the currency to dollars, even though on the screen here it's listed as dirhams. But anyways, the amounts are the same. You're better off going with Plan 1. Even though Plan 2 does monthly compounding, it's still, that monthly compounding isn't enough to overcome the higher interest rate that's offered by Plan 1 compared to Plan 2. Okay, so here was the compounding problem for a credit card. And you can see why the banks like to do this daily compounding is because what looks like a 24% card turns into a 27% card if they're compounding your interest daily. Okay, the cash flow diagram should look like this. Boy, better than that. This should look like this. So the key elements of this cash flow diagram, of course, you should always include the labels, the A, F. If there was a P, a present value, then you should include those labels. Inflow amounts are up, outflow amounts are down. If you have an annual series and a single payment in the same year, then typically it's best to keep them separated, because if you combine them, then you lose the ability to do some of the translations I'll show you later on. Because later on in the semester, for example, we'd maybe ask, what's the present value of all of this? And so you're moving it all to year 0. It's easiest to do that if you leave the A's separate from combining them with the single amounts. Okay, so this is all I have for you today, the in-class exercise. Just as a reminder, it always pays to get an early start on the homework, so I'd encourage you to get started on that right away. I'll see you on Friday.
These formulas be provided on an exam?
Yeah, they will.